Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about time series analysis, index numbers, statistical quality control. As part of statistical quality control, we talked about control charts. There are 2 types of control charts for variables and control charts for attributes. In the previous session, we talked about control charts for variables, computation of UCL, LCL and CL for X bar chart, R chart and S chart. In this session, we are going to work out some examples in control charts for variables to understand the concept further. A construction of control charts for X bar and R, that is plotting of central line CL and the control limits, upper control limit and lower control limit. Actually, control charts are plotted on a rectangular coordinate axis, vertical scale ordinate, that is x axis, representing the statistical measures x bar and r, and the horizontal scale abscissa representing the sample number. The sample points mean or range are indicated on the chart by very small points which may or may not be joined. For X bar chart, the central line is drawn as a solid horizontal line at X bar, and UCL and LCL, that is upper control limit and lower control limit, are drawn at the computed values as dotted horizontal lines. If the sample size is 7 or more, n is greater than or equal to 7, then the range LCLR, lower control limit R, is drawn as dotted horizontal line at the computed value. Otherwise, for n is less than 7, if the lower control limit happens to be negative, then we take it as 0, because negative values are never plotted on the graph sheet. Next, control chart for standard deviation or sigma chart. Since a standard deviation is an ideal measure of dispersion, a combination of a control chart for X bar and standard deviation S, known as X bar and S charts or X bar and sigma charts, is theoretically more appropriate than the combination of X bar and R charts for controlling process average. Process average will be controlled by X bar chart and process variability will be controlled by S chart instead of range chart. In a random sample of size n from a normal distribution with standard deviation sigma, we have expectation of S square is equal to always n minus 1 by n into sigma square. So, expectation of S equal to C2 sigma, where C2 is taken to be equal to root of 2 by n into n minus 2 by 2 factorial by n minus 3 by 2 factorial. Okay. And variance of S is equal to expectation of S square minus E of S whole square, and this is n minus 1 by n sigma square minus C2 sigma whole square. So, this is n minus 1 by n minus C2 square by into sigma square. This implies standard error of S is equal to root of variance of S. So, a standard error of S is equal to C3 sigma, where C3 is equal to root of n minus 1 by n minus C2 square. So, now we will talk about UCL of S. UCL of S is expectation of S plus 3 times standard error of S. Expectation of S, if you see, it is C2 sigma and standard error of S is C3 sigma. So, C2 sigma plus C3 sigma, which is commonly 3 times, right? 3 C2 sigma plus 3 times C3 sigma. So, C2 plus 3 C3 into sigma, which is equal to B2 sigma. And similarly, we have B1 sigma. I will tell you what is B1, B2. Before that, let me finish. LCL is E of S minus 3 times SE of S, standard error of S, and control line for S is C2 sigma. Now, what is B1? B1 is C2 minus 3 times C3, and B2 is this part, C2 plus 3 times C3. Control limit, control line or central line for standard deviation S is C2 sigma, okay, where C2 is in the usual notation already discussed. Now, the values of B1 and B2 have been tabulated for different values of n. If the value of sigma is not specified or not known, then we use its estimate based on S and given by sigma cap is equal to S bar divided by C2. In this case, UCL of S becomes E of S plus 3 times standard error of S is E of S is S bar plus 3 times C3 by C2 into S bar. So, what happens? It is 1 plus 3 C3 by C2 into S bar. Similarly, we get LCL of S if the sigma is not known. LCL of S is 1 minus 3 C3 by C2 into S bar. So, in short, UCL of S is B4 into S bar and LCL of S is equal to B3 into S bar, where B4 is 1 plus 3 C3 by C2 and B3 is equal to 1 minus 3 C3 by C2. And CL, control line for S, in all the cases whether sigma is known or not known, we have CL of S is equal to S bar and CL of S is equal to S bar, where the values of B3 and B4 have been tabulated for different values of n. Since S can never be negative because S represents standard deviation, it is a square root value. A square root value can never be negative. If LCL comes to be negative, as will be the case for n from 2 to 5, it is taken to be 0. Let us see this example. Construct a control chart for mean and the range for the following data on the basis of fuses, samples of 5 being taken every hour. Each set of 5 has been arranged in ascending order of magnitude. Okay. And the question is, comment on whether the production seems to be under control, assuming that these are the first data. Sample 1 values are 42, 65, 75, 78, 87. What is given in the question? Samples of 5 are being taken, that is each set of 5 has been arranged. Every hour it is taken. So, for 12 hours it is taken like this. Every hour it is taken. So, samples are 42, 65, 75, 78, 87. Similarly, this is 2 starting from 1, 2 etc. up to 12 hours it is calculated. And we have to calculate x bar, r bar, and we have to compute UCL of x bar, LCL of x bar, CL of x bar, and UCL for r, LCL for r, and CL for r. All the 6 values have to be calculated using the appropriate formula, and that has to be plotted on the graph and afterwards we have to comment using the graph drawn. So, just to take the sample numbers are 1, 2, 3, 4, 5 etc. up to 12 and the sample observations. For sample 1, the sample observations are taken for 5 hours as 42, 65, 75, 78 and 87. The total of these 5 values are 42 plus 65 plus 75 plus 78 plus 87 gives you 347. Then sample mean, in the sense 5 values are added, therefore the total divided by 5. So, 347 divided by 5 gives you 69.4. Then talking about sample range R, what is the maximum value? The maximum value is 87 and minimum value is 42. It is not necessary the maximum value will always be the fifth sample or that is the last sample observation, and the minimum value is always the first observation. It can vary also. So, here in this sample highest value happens to be 87 for sample 1 and minimum value is 42 for sample 1. So, range is 87 minus 42 gives you 45. Likewise, we have calculated for sample 2 the 5 values of 42, 45, 68, 72, 90 and the total is 317 divided by 5 is 63.4 and the range is just see 90 minus 42 is 48. Okay. Likewise, the values are calculated and the total is written here. Okay. That is this value 859.2 is summation x bar and this is summation r. So, summation x bar values is 859.2 and summation r is 716. Let us see how the values are calculated for UCL, LCL and CL. Okay. So, first from the above data we get x bar bar is equal to 1 by k summation x I bar. So, how many samples are given? 12 samples are given and the summation of sample means has come to be 859.2. So, 859.2 divided by 12 is 71.6. So, x bar bar value is 71.6. Okay. And then talking about r bar is a summation r divided by k. Summation r comes to be equal to 716 and there are 12 samples, therefore 716 divided by 12 is 59.67. So, r bar is equal to 59.67. We have to calculate x bar chart. For x bar chart, UCL of x bar is x bar bar plus A2 into r bar and LCL of x bar is x bar bar minus A2 into r bar and CL of x bar is equal to x bar bar. This particular value CL of x bar bar is 71.6 and UCL of x bar bar is 71.6 plus A2 value. We will just take it from the tables. I will show you how the table is taken and R bar is 59.67. Okay. Just refer the tables. Here n is equal to 5 and for 12 hours the values are noted. Therefore, 5 observations are given in each sample, right. Sample numbers is different from sample size. Number of samples is k, sample size is n. Here in this graph it is shown as m. Therefore, A2 value for the sample size of 5 is 0.577 or shortly we take it as 0.52 and then D3 value is also required, D3, D4. So, D3 is 0 for n is equal to 5 and D4 value is 2.114, this 2.114. Okay. A2 value from the tables is 0.577 and then D3 value we need, I will just write D3 is 0 and D4 is 2.114. Okay. So, now at present A2 is required. So, 0.577 is substituted here. So, 71.6 plus 0.577 into 59.67 is 106.21. Similarly, here 71.6 minus 0.577 into 59.67 is equal to, the value is 36.99. Okay. So, this has to be plotted in this graph. The graph shrunk from the starting point 0 and the shrunk is shrunk up to 40. Therefore, first point is 40, 50, 60, 70, 80, 90 and 100. First of all, 36.99 is plotted here and 37 nearer value. It is plotted like this and this is LCL and the value is 36.99. So, LCL of x bar, and then 71.6, 71.6 means almost 72 and it is drawn with bold lines. 72, the blue line is representing the control line. CL of x bar is equal to 71.60. Okay. And then 106.21, this is 110. 106.21 is nearer to 106 and 106 is here somewhere, therefore, this point. This is UCL of x bar is equal to 106.21. And all the sample values are just plotted. See, for sample 1, what is the first value of sample 1? Sample 1, the first value is 42, then 65, 75, 78, 87. So, all the values will be plotted in this graph. I will just write down for first sample and second sample. So, for the first sample 42 is plotted. Then for the second sample 65 is plotted, 65, then again for the first sample second observation, then 75 is plotted, then 78 is plotted, okay. Then 87 is plotted second. This is for sample 1. Similarly, for sample 2 you plot 42 again, then 45. Likewise, the points are plotted in the graph sheet and then we will be able to see whether there is any out of control or in control values. When you look at the data, any value which is greater than 106.21 will go out of the control of the process. Therefore, then we will be able to say that the process is not under control. Now, similarly, we will draw the R chart. R chart. The calculation is UCL of R is equal to D4 into R bar. D4 is 2.114 from the tables into 59.67. The value is 125.90 and LCL of R is D3 into R bar. D3 value is 0 and CL of R is equal to R bar value 59.67. So, we have to plot 59.67 and 125.9 in the graph sheet. So, the starting point is taken as 0, again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and then 12. Since we starting point we need it as 60, like that we need after 60 directly we need 125.9, 126. So, I will take the scale as 20, 80, 100 and then 120 and then 130. Okay, we need the value 59.67, 59.67, 0 and then 125.904. So, first of all drawing the LCL drawn with a maroon color. 59.67 is almost drawn here, and this represents CL of R is equal to 59.67. It is drawn with the dark lines, okay, and lower limit is drawn with dotted lines. That is 0, it is on dotted lines, and this is LCL of R is 0, and then 125.9, that is 126 is drawn here. இல்லை ஆக்சுவலாக நான் இன்னொரு வாட்டி போட்டு தரணும் சார், இப்போதைக்கு பாயிண்ட்ஸ்லாம் ப்ளாட் பண்ணி மார்க் பண்ணி தரேன். இப்போதைக்கு இது வரையட்டும். ஓகே, then UCL of R is written is drawn as 125.9, therefore it is almost 126, so dotted line on 126, and this is UCL of R is 125.904. Okay, again plot the points, plot the sample 1 values, sample 1 values is sample range. First of all is plotted as R value is 45 for the first sample. First plot 45, I will plot in yellow color. Okay, for the first sample, the sample range value is 45, 45 is plotted somewhere here, and second value is 48, 48 here, and then 62, 62 is above, and then 48, and then similarly the range values starting from 45 to 75, that is sample range R values we have just calculated, that will be plotted. For the fifth sample it is 36, 36 is also plotted somewhere here, and 81, 81 is plotted here, 78, 78 okay, 42 is plotted somewhere here, okay, and then 69, 69 is plotted here, then 84 is plotted here, and 48 is plotted somewhere here, and then 75 is plotted here. This is R chart. Okay. So, you can see all the values are within the control, whereas in X bar chart X bar is plotted as first value 69.4, 69.4 is somewhere here, and then 63.4 likewise it is plotted, and from the X bar chart clearly the process average is out of control, since the points sample means corresponding to 8th and 10th sample, corresponding to 8th sample we have 46, and corresponding to 9th sample is 112.4, lie outside the control limits. So, the points corresponding to 8th and 10th samples lie outside the control limit. In R chart, since all the sample points, that is ranges, fall within control limit, this chart shows that process variability is in control, whereas process average is out of control because of the ninth sample. Ninth sample is actually 112.4, it goes beyond 106.21. Therefore, particularly because of the ninth point, ninth observation, we are able to say that process average is out of control. Although R chart depicts control, the process cannot be regarded as a statistical control since X bar chart shows lack of control. The choice between X bar and R chart is a managerial problem. It is better to construct a R chart first. If the R chart indicates the dispersion of the quality by the process is out of control, it is better not to construct X bar chart at all until the quality dispersion is brought under control. In this session, we talked about control charts for variables. We have also worked out an example in drawing control charts for X bar and control chart for range, and we have plotted the points and we have drawn UCL, CL and LCL for X bar and R charts. And after plotting the points on the graph sheet, we see that in X bar chart there are some points which goes out of control, or that is out of the coverage area of UCL, and in R chart all the points are under control. Although process variability, that is R chart consists of all the points between UCL and LCL, since X bar chart is not showing control, we would ultimately interpret the result as whole process is not in control. Based on the discussion, the following question may be posed. The following data shows the values, sample numbers and sample mean X bar values and range values for 10 samples and each sample consisting of 5 items. So, calculate the values for central line, control limits for mean chart, range chart, and determine whether the process is in control. Thank you.